When you open up your Epic 280 ARF kit, this is the V2, this is what's included in the package. We have 4 arms, 4 millimeters thick, the top and bottom plate of the dirty frame, the top and bottom plate of the clean frame, a jet seat for holding your GoPro. This is the 50mm height version because this kit comes with 50mm standoffs. The Naze 32 board, the wire harness for a PWM setup, the straight and angle pins, 4 30 amp ESCs. These have one-shot and dampened braking, 4 2208 T motor, 2100 kV. Each motor comes with an accessory bag, as shown here. The hardware pouch, and inside the contents are a Velcro strap, 14 gauge LiPo wire, 50mm aluminum standoffs, 16mm and 12mm aluminum standoffs, 8 arm spacers, the V2 bobbins, power distribution board, Dean's connector, 4 aluminum caps designed for M3 hardware. We have the nylon threaded M3 lock nuts, the 6 and 20mm button head. So this is where I sort of take the time to organize the hardware and group them into the same sizes. It makes building later on a lot faster and a good way to keep the hardware instead of just a big pile. Now this is an optional step in building any carbon fiber Miniquad, but really I find it's this little detail that will make your build that much better. And the carbon fiber plates, cut from the factory and pretty much just shipped to you, they have rough and sharp edges. And there's certain spots on every frame part that we know the wires will be traveling out of the hole or going by, so it's a good idea to get the edges sanded or filed down so that it's smooth. I use a 600 grit, and I love this because you can actually sand it while running underwater. And there's 2 great things that this provides. One, there's a lot of dust that gets created, and we all know carbon fiber dust is very harmful to our system. So unless you're wearing a mask or doing it outside, this is a good way because it's constantly being wet and it will take the dust away. So that's reason number 1. Reason number 2 is that the water actually helps the quality of the sanding, and the finish becomes really, really nice. So it's something I enjoy. This is the top plate of the dirty frame. The most important part that needs to be rounded is this circle. And it's because all the ESC signal wires will be coming out of there because the ESCs are mounted on the bottom, right? So in this hole in particular, I'm going to be using a file to get the edges from the top side and the bottom side to be smooth. So I like to hold the file close to the tip, kind of like a pencil. It gives me good control of where it's going to go. And take it slow. You don't want to run out and draw a scraping line, right? And that's the reason why I hold it down like this. And you're not going to be that rough with it. And change your angle of attack as you work your way around. Now, I always feel it with my fingers and see if I need to do any more spots. And I know people are saying use gloves for this, but for sanding, I can't do gloves because it's a very tactile feel, and I need to keep going back and feeling how much or how little I have to do. So get your board wet. I'm going to get a little more water. Get your sandpaper wet. Now try to start with a small piece because you don't want a lot of overhang, which then will start to scuff the face of the plate. And if you do that, you've sort of committed yourself to doing a whole sand job of the entire plate. So take a small piece, and really, you're just putting it on your fingertip or on your thumb tip, and you're using that as a sanding sponge. So notice I'm just exposing enough sandpaper and holding it in about a 45-degree meeting angle, and I'm just rolling it back and forth. And that's going to be done on the one face, and then flipped over again and done on that side. Again, this isn't a lot of pressure, right? We're not trying to change the contour of the frame. We're just smoothing out and rounding out the edges so it's not that sharp. Feels smooth. And that's it. Okay, once that's done, put it on your drying rack. Okay. So we're gonna go over which parts need some extra filing because they are holes that are used for wires to come through from the bottom. So these 3 holes in particular, they need to be carefully filed out so that the edges are round. These ones back here, you can do them as well, but usually we don't have anything coming out from the back. But it doesn't hurt to do the big ones, right? So those 7 holes you can take care of. And again, sanding the edges and all that. The arms are pretty easy. These just on the edges. The bottom plate of the dirty frame, that is the same as the one we just did, just on the edges again. And this is the top plate of the clean frame. Again, all the edges like everything else. And then these cutouts here, if you want to, you can file them out. These circles here, a lot of people use to route the VTX wire. There's actually a grommet that we can insert if you don't want to take the time to use a file. It's up to you. You can round out these holes with the file. The smaller they are, they get a little trickier, so it's up to you, right? So I've laid out on the table all the parts that come in the kit to assemble the bottom plate and the arms of the dirty frame. And essentially, on every arm, we need 2 spacers, 3 20mm M3s, and 3 M3 nylon threaded lock nuts. For the sides, we need the 12mm aluminum standoff and the 6mm M3 button head. Now, the way it was designed to be built, you take the bottom frame, you insert the 3 20mm M3s, you take a piece of tape, and you stick it to the bottom so that the hardware won't fall out while we work on it. So then you flip it over. You insert the 2 carbon fiber arm spacers. And let's get that in there. Okay, make sure the tape doesn't fall out. And we'll insert the second one. Then finally, we insert the arm. So it's going to sit on the table like this with all 4 of the arms in this fashion while we mount the motor and we mount the ESCs and the power distribution block in the middle. And after that, we take the top plate and we're going to sit that on top, and we're gonna tighten down the 3 M3 lock nuts. So this is how it was designed to be built, and it's really good. The spacers act to be a really rigid platform. The disadvantage to this is more sort of an aesthetic thing where the motor wires coming from the motor has to travel down the arm but swoop into the channel to get into the ESC. And some people don't like that. They found a better way, and I'm gonna say they found an alternate way. So what we do instead is, for that, we need 12 more M3 lock nuts, and we only will be using one spacer, then the arm, then we're going to tighten down the 3 lock nuts, so it actually makes it very stable on the bottom plate, so we don't need the tape. And then we work on everything, and because we have the height of one of these lock nuts, it creates a little channel where the wires can run through into the ESC bay. And after that, we put down the top plate and another M3 on top to hold everything together. It's up to you how you want to do it. I prefer having the wires run into the channel that we created into the ESC bay. So I'm going to go ahead and do that. And let's start. So we're going to need a 2.0 millimeter Allen driver and a 5.5 millimeter socket. These little guys are pretty handy. So we're going to start the same way. We're going to insert the 3 20 millimeter M3s. This system, you can actually just hold it with your thumb. You don't need a piece of tape. And we're going to insert one spacer. Then we're going to insert one arm. Remember, we're using the stainless steel to match these standoffs. So you can start it by using your thumb until you feel resistance, just to get it locked in there, or attached to it. And there we go. And here as well. So it's going to look like this. Now, it's loose, but it's going to hold still. So we're going to use our socket and hold it. And we're going to use our driver. So we're going to tighten down on all 3. Now, if you have any configuration of bolts that is holding a piece, do not tighten one by one really, really tight. You want to ease it in. So you want to take one so that it feels the first contact of resistance. And really, you're just using a very little amount of pressure. So that's stopped. Then we go to the next one. And again, you only want to stop when you just feel the resistance. Stop. And the last one. And doing it this way, you're going to give it equal amount of pressure, and it's the best way to tighten a series of bolts. Okay, and we stop. So then we go back to the first one. We inch it a little bit more. We go down a little bit more. Then we go to that one a little bit more. And then we keep doing this, increasing pressure each time. And this way, you'll start to get a better distribution between each of them, and less likely that it's going to be crooked or it's going to have uneven amount of pressure warping the frame in some instances. So normally I do that one first, then that one second, third, back to that one, second, third. If you have a 4 system, you want to go top, bottom, left, right. Top, bottom, left, right. Now I'm starting to increase the amount of pressure I'm using on the Allen driver. Okay, and there we go. So in this setup, you've got the bottom frame and the arms on there pretty tight. And it works better this way, I find, because it's all connected now. And for doing repairs, you just take off the top plate and you change whatever you need. And it's always going to be one system. Plus, it provides the little channels that the wires can run through. So I love this way. So I'm going to go ahead and finish the other arms. The assembly of the bottom plate and arms are finished. Now what we've got left are the side standoffs. So what I like to do is, these are quite nice, but I like them a little bit shinier. So we can take one of the 20mm M3s and we'll screw that on there. And we're going to use a polishing compound to shine it up, to make it a little bit shinier and smoother. If you look at these close up, they're nice, but I think they can be a little bit better, right? So you can use all kinds of products, but I really like this. I have a lot of things that are plexiglass and plastic, and I've got a lot of products from this company, and it works really well on polishing aluminum as well. So get a lint-free cloth. At Home Depot you can actually get a big box of painter's rags. I think it's called Box O rags, and it's fairly cheap, and you can cut them into small pieces, and I use this. So with this product we're gonna add a little bit onto the cloth. Okay, and we're going to polish. And you can see it working. I've done all kinds of ways and even used a Dremel with the polishing compounds that they sell, but honestly this product here works really well, and it's not that much effort. You can see I'm just rubbing in the product, and I don't know if you can see that on the camera, but noticeably shinier and smoother. And just from a little bit of rubbing that product. And this is what I use. And here we go. I think it looks much better. So let's do that to the other one. So we're going to take the second one here, and let's see if we can see a side by side of the two. You can see that the specular highlight is a lot tighter on the one on the left, and it shows that it's got a high level of reflection. I like it. So this one needs to be still polished. Now, an alternate way some people are treating these standoffs, because some people don't like the shiny aluminum, they want it to be black. So if you really want to, some people put heat shrink over these standoffs, heat it down, and then trim off the edges to make them black. But I don't know, for me personally, I really like the shiny aluminum. It's a nice look. Okay, so that one's ready. So there's one last step before assembly, and this is common to all M3 hardware that's included. Well, with any kits, right? Because we have to thread lock, any time you bolt hardware into metal, it's going to vibrate free after a lot of flights. So we use a thread lock. You know, a common one is Loctite. But to get the best bond, we need to clean off the residue that's on these fasteners. And a lot of people don't sort of pay attention to that, but it actually makes a huge difference. So what we need to do is get a different cloth, the same one, the lint-free painter's rag that I like to use. We take some rubbing alcohol, then we're going to rub the threads. And this will remove any of the manufacturing process residue that's left behind. And if you do that, you can see on the cloth some of the stuff that's being cleaned off it. Now, some hardware are worse than others. This one actually seems pretty good, but still, it's getting off everything we need to. So we do it for the second one as well. And I've seen some where it's just black from cleaning. And if you had that, the thread lock won't bond as well as it should. And yeah, you can see right there, it's getting a lot of the residue off. Okay, so we've done that. We've got the two standoffs. Now we're gonna assemble it. So we're gonna, how it goes is M3 goes in, standoff screws in. So in this case, the best way to apply the thread lock is first put the M3 6mm, hold it with your finger, get the thread lock, and these bottles pour out quite a lot, so don't put that much pressure. And we want to apply some on the end there. Now, too much is bad, so if you get too much on there, a good way to do it is take your finger and rotate around. And that takes the extra excess off, and I like to keep a cloth here, and leaves enough on there. So using your standoff, we want to screw that in. Now, anytime you use thread lock, try to go in and out, and then finally in. Now, while holding that, let's see, our driver again, and we tighten it in. Now, the problem with rounded standoffs is it's hard to hold, because normally if we have a hex one, we just insert our socket and to hold it in place. With the round ones, it's very slippery. So what I've done for my builds is I've taken a needle nose and I wrapped an elastic band around it, because if you just use needle nose, you're gonna gouge out the standoff and it's gonna look pretty ugly. So wrap an elastic band on the end while holding it. We're gonna do the final tighten, and there, it doesn't scuff up the standoffs. So I actually, in my tools, I keep two. One needle nose that has the elastic, and somewhere, oh, here it is. And my second that is non-elastic. So those come in handy. So let's do the second. Again, put the M3 6mm. While holding it, we want to apply the thread lock to the end. And you can see that one is quite a lot of thread lock, and that's too much. So we want to take our finger and we want to roll it. And our finger sort of acts as a sponge. But still, it's not absorbent like a cloth. So if you used a cloth, you would just suck up the entire thread lock. But by using your finger, you're just taking just the surface amount enough. So with that, again, we hand thread our standoff going in and out. And each time going in, a little bit more, and then finally back in. I put away my needle nose rubber band. I'll grab that. And we're gonna hold that again. And the final tighten. Okay. Bottom plate, arms, standoffs, they're done. So let's move on to motors.